Okay, so today we're going to be learning about measurements, specifically temperature. Temperature is defined as a measure of how hot or cold one object is relative to another. So with temperature, we always have to consider another object. So say, for example, you have an ice cube in your hand. You would say that the ice cube is colder than your hand due to the difference in temperature. Now, one of the things about temperature is that it is not the same thing as heat. And we'll actually be looking at this quite a bit towards chapter 6, but heat is defined as when we have an energy that flows from the object with the higher temperature to the object with the lower temperature, which would be the colder object. So although the two are different, they are actually related in that temperature determines the direction with which heat flows. Now, commonly with temperature, how do we measure it? Well, we use a thermometer, and you will be using this technique in lab this semester many times. Now, basically what happens with a thermometer is that when you immerse it in a substance, what's going to happen is that if it's in a hotter substance, the liquid inside of the thermometer is going to expand and rise, and if it is in a colder substance, then it is going to contract and go lower. Now, within a thermometer itself, you're usually going to see one of two things. You're going to see red liquid or silver liquid. The silver liquid, as you know, is mercury, and the red liquid is an alcohol. And we typically tend to use the alcohol thermometers because mercury thermometers have been known to be, well, mercury in general has been hazardous in the past. So we tend to stick to the alcohol safer thermometers. Now, what we're going to look at specifically with temperature is three temperature scales. So we have what's known as the Fahrenheit scale, the Celsius scale, and the Kelvin scale. The Fahrenheit and Celsius scale you should be fairly familiar with. The Kelvin scale, this is actually the scientific scale. So as a scientist, this is our go-to temperature scale that we use and how we make our measurements when we are taking temperatures. Now, all three of these temperature scales are based on the physical states of water. So these are based on physical states of H2O. Oops. And with these, what you're going to see is that it's based off of the point with which H2O freezes and the point with which it boils. So, if we look at the Celsius scale, we see that at 0 degrees C, this is when water freezes on the Celsius scale. And H2O boils, meaning it goes from a solid or a liquid to a gas at 100 degrees C. Now, in between, the difference between the two phases is actually 100 units. Okay, now, if we compare this to the Kelvin scale, what you see is that on this temperature scale, we start at a different point. Here it has 273.15, but in actuality, it's actually 273.15 Kelvin. Now, we have a different starting point compared to the Celsius. However, if we look at the boiling point, we have 373.15. The difference is still 100 units. So, conversion between these two temperature scales is going to be relatively easy because we only have to account for the difference in starting point, meaning 0 degrees C and 273.15. The difference in units, 100, is both the same, so it makes converting much easier. Now, the Fahrenheit scale, this is actually the scale that you should be most familiar with. And in this particular scale, water freezes at 32 degrees Fahrenheit, and it boils at 212. Now, as you can see, compared to the Celsius scale, we have different starting points, so it's 32 rather than 0. Now, in addition to that, we don't have a difference of 100 units, but rather 180 units. So when we convert between these two temperature scales, we're not only going to have to account for the difference in starting points, but also the difference in the units, whether it be 100 or 180. So that's one of the things that we need to learn how to do, is to convert between temperature scales, and again, based on the physical states of matter. So, when we look at Celsius and Kelvin, and we convert between these two scales, okay, we already know the freezing and boiling point for Celsius and the freezing and boiling point for Kelvin. And the difference between two of these is 100 units. Now, there's a few additional things about the Kelvin scale that you should know. One is that there are generally no negative values with this scale. So we actually have the lowest value on the Kelvin scale, which is 0K. This is what's known as absolute zero. And at this temperature, matter ceases to move, in theory. Now, the reason I say in theory is because we haven't quite hit that temperature yet. We've been very, very close to that temperature. However, we haven't quite achieved 0K. So, in theory, at this temperature, all matter will stop moving. So, on this temperature scale, we don't have negative values like we can see for the Celsius and Fahrenheit scales. Also, we don't use a degree symbol like we do in the Fahrenheit and Celsius scale. So when we say that we have a temperature in the Kelvin scale, we say it is 10K, or we say it is 100K. We don't say it is 10 degrees K. All right, now, here I have two formulas that you need to know. And make sure that you know these because we will be using them throughout the semester quite a bit when we start looking at gases and also heat. But basically, it's a way to convert between Celsius and Kelvin. So, because the Celsius and Kelvin scale because the Celsius and Kelvin scale have the same difference in units, meaning 100 units between boiling and freezing. Whoops. We don't have to account for that in our conversion. So, what we do is we either add 273.15 or subtract 273.15, depending upon which direction we're going. And this is to account for the difference in the starting point, whether it be 0 degrees C or 273.15 K. So these two formulas are the ones that you need to use when converting between Kelvin and Celsius. So make sure that you know those, as they will not be given to you on the exam. Now, Fahrenheit's a little bit more difficult because, again, we have a difference in our starting point, but also a difference in the units in between. It's no longer 100, but rather 180. So when we convert, we have to account for the difference in the starting point and account for the 180 units. So how we do that is compare it to 100. So we either are going to have 9/5 or 5/9. So the formulas for converting between Fahrenheit and Celsius are given here. And again, these are two more formulas that you need to know. They will not be provided to you on the exam. But basically what you can see is that when we go from Celsius to Fahrenheit, we multiply by 9/5 and add 32. If we're going the opposite direction, we subtract 32 and then multiply by 5/9. Now the 5/9 and 9/5 is to account for the unit difference, okay, whether it be 180 or 100, and we either add or subtract 32 to account for the difference in starting points. Okay, so you have four formulas with temperature that you need to make sure that you know. Now, before we finish, let's do an example, because everybody at some point is going to have to take a temperature and decide whether or not someone is sick. In addition, many of you will be going into the medical profession and will have to do this as well. So, if we have a child who has a body temperature of 38.7 degrees Celsius, well, you know that 98.6 degrees Fahrenheit is normal body temperature, and anything above that is considered to be a fever. You need to determine whether or not this child has a fever. So, if we look at what we have, we see that we want to convert degrees Celsius to Fahrenheit. So we know we want to use the formula degrees C times 9/5, and we add 32. So if we plug in our temperature and do our calculation, we see that we get a value of 101.66 degrees Fahrenheit. So this child does indeed have a fever and needs some medication. Now, this temperature isn't the exact final temperature because you have to remember to account for significant figures. Now, with temperature, we treat them the same way that we would treat an addition or subtraction problem, which means we have to go by digits past the decimal place. Now, within this problem, we have 9/5 and 32, which we consider to be exact numbers. So we do not consider them when accounting for significant digits. The only measured number that we have and that we used in this formula was 38.7. So if we look at this, we see that this has one digit past the decimal place. So that means that our final answer can only have one digit past the decimal place. So what you see is that we have to get rid of this 6, and since it's above 5, we know we have to round up. So the final temperature that we would report would be 101.7 degrees Fahrenheit. Now, if we were to take this a step further and convert it to Kelvin, we know that we would go from Kelvin to Celsius. We have to add 273.15. And since, again, this is temperature and we want to account for significant figures, we want to line up our decimal place. So we would have 38.7 plus 273.15. We draw our line past the number with the fewest digits past the decimal place. We do our addition and we get 311.85. And since this is a 5, we know we would need to round up, so our final answer would be 311.9 K. So, with temperature, you have to remember that it's based on the physical states of water, at what temperature they freeze and boil. You also need to remember the 4 equations that allow you to convert between all 3 of these temperature scales. And you need to remember to account for significant figures, and you treat it the exact same way as you would an addition or subtraction problem. So digits past the decimal place.